It's an important concept. It's not so important the term, like if you, for example, picked, in this case we had 4 bars here, right? If you picked 4 or someone else picked 5, you would still have the same shape. Your bars would just be narrower, right? You're having smaller boxes, quote unquote. So I wanted to, unfortunately, I cannot have it on my iPad, so this is not going to be on the video, but if you're in class, you'll see it. So this is just a different class here. And so this is the distribution of a class, right? In bar, right there, there's several bars. They're not touching, so in that case, it's not technically a perfect histogram. But there are 10 bars here. I can choose to decrease the amount of bars that I'm using. What's happening to the bars? The fewer I have, technically, the wider they become. And so basically the width changes. So you're just putting some values in these boxes now. You only have 5 columns, right? You could reduce it even more, right? And so the more columns you have, there are going to be slight variations along the way, right? Because you're getting narrower and narrower when it comes to the bars. But the overall is still going to stay the same, that it's like increasing like this, right? So don't fixate too much on the columns. I will give you that for a test or AC quiz. I will tell you how many. Quite often the worksheets also tell you how many to choose so that we're all kind of on the same page. Okay. So yesterday we started, this is on page 10, right? We were given some, what is this, flow rates of the Red River in meters cubed per second. There were 30 years of data collected. We figured out the MCTs, the standard deviation, and the range. And then we wanted to create a frequency table. We wanted to choose the width of the bars, right? So one way of doing that is to take your range and divide it by the number of bars you're trying to create. We chose 10, right? So we took the range, divided it by 10, we got 442, and we rounded it to 500. That's what you want to do if you do one of these, okay? You will notice that soon we're going to actually just use our standard deviation as our bar width, okay? But in this case, we rounded it to 500, and then we decided, okay, like I'm going to start at 0 and go up by 500. Why 0? It's just convenient, right? And you're placing the values in there. So I hope I still have them on a calculator. So if you have your calculators, right, have those out too. Hopefully you still have the numbers, these numbers that we've entered into L1. And I'll show you the quickest way of filling in a table like this. So you want to sort it, right? Sort L1, that's what I'm going to do. Go back and check it out, right? And so now you have them arranged, right? And so I kind of ask myself, let me see if I can fit that in. So the 159 would definitely fit into the 0 to 500 category, right? 187 as well, 280 as well, 396, 500. Where would that go? Because you've got 2 options, always in the lower bracket. Okay, if you have a choice, it goes in the lower. So that's 5 values, right? As soon as I get to 564, I'm into the next category. So 564, 881, 946, 991, and that's it. Because the next one is 1048. That already gets me into the next category. So that's how you do these. 1121, 1390, 1393, 1399, 1458, 1557 gets me to the next one, right? 1589, 1670, 1750, that's 5, 1807, 1812, 1877. 2080, I already jumped to the next category. And if you get it, you just do it, right? 2718 gets me into the next category. There's only one in that category because then I go 3030, which is already in the next one, 3058. And then watch what it does. I go from 3058 to 4587. So I kind of jump this box. I jump this box. There's nothing in there. It's actually in the last one here, right? 4587. And so, yes, there are some bars that are going to be zero, right? There's going to be nothing in there. And it's because that value was 4587, which is in between these two limits, right? So then you just go here and once you've tallied it, this is like as you're counting, right? As you're filling in, you're filling this in, and then you say, okay, there's 5 in the first one, 4, 6, 8, 3, 1, 2, 0, 0, and 1. And if you add this up, you want it to add up to, sorry, you can't see that, right? Sorry. So right now you fill this in, and you want to make sure this adds up to 30, right? Because you have 30 values that you've placed in there. So this is what I'm going to check most of all. I'm not necessarily going to check this part. I'm just going to quite often just check to make sure this actually adds up to 30, right? And there you go. So now this is what we call the frequency table, right? You need this to do the two graphs, right? The frequency polygon or the histogram. So let's go ahead and do that. Okay, so you basically are going to make these appear on the x-axis and this appears on the y-axis, right? So this goes into your x-axis, this goes into your y-axis, right? The frequency. So we're going to go ahead and do that. So this is frequency. And in this case, it's number of years, right? Like the years it happened, right? Number of instances. And along the x-axis, we're going to have flow rate. And that flow rate is measured in cubic meters per second, right? And when I created this, I probably, let's see, 0, because it starts at 0, you don't need a zipper, right? So 0 to 500, 1,000, 1,500, 2,000, 2,500, 3, 4, 5,000. Yeah, so this works out quite well if I just go up by 500, right? So 500, 1,000, 1,500, and so forth. And if no grid is provided, just make sure you use a ruler and they're equally spaced out. So adjust the scale accordingly, right? So no zipper, I reiterate, because we're going from 0 to 500, so you're consistently going up by the same amount on the x-axis, so no zipper required. Along your y-axis, you just look at your frequency, these numbers in here. Like what's the highest number in there? I see 8, right? So technically we can just say, okay, 5, 10, right, and 15. That will work just fine for us. So at this point, it's just a matter of creating the bars, right? So from 0 to 500, we have 5, right? So the bar should go up to 5 and come down like this. From 500 to 1,000, we have 4. So that bar actually goes down like that. right? We got 5 here, 4 there. Then we have 6, so that goes up to here. 8. And I have 3. 1. 25 to 3,000, just 1. 3,000 to 3,500, there are 2 years where you had a flow between these two values. And so basically you want to group values. That's what we're doing here, grouping them up. Because a bunch of individual values is harder to see the big picture. Okay, so we're basically using this to analyze. So these are 0, right? From here to here is 0, and from there to there is 0 as well. So we have the last one is just 1. Like that. This is a histogram. Okay, right now this would be a histogram. And to create the frequency polygon, I showed you the trick, right? You just connect the midpoints of each bar. Because you have an appropriate scale along the bottom, this is accurate, right? To just take the halfway point. And watch this, the 0 bars, there's still a midpoint, right? And it goes up like that. And we want to close it every time. So it doesn't matter where necessarily, just I'm going to start right at the origin here. Oh, what happened to my blue pen? Hasn't been used. There you go. Okay, so that's our frequency polygon right there. Look at that. Colorful. And then just make sure you close it off, right? Right. There you go. So the hardest part, in my opinion, is to come up with your frequency table. Okay, the table we just created up here. But don't be too scared of like how many bars, right? If you would have picked, to be quite honest here, if you would have chosen to go up by 1,000, right? So instead of 500, you went up by 1,000, so it would have been 0 to 1,000, 1,000 to 2,000. You would have just had fewer bars, right? You wouldn't have had to fill in this whole table. And that's okay, that's all right. Sometimes perhaps if too many bars are empty, we kind of make the bins a little bit bigger, right? To have more stuff in there. But this would be accurate. So I want to say one more thing. So let's go back a page. to page 9. And at the bottom of page 9, you should have a little bit of space there. I'll just tell you this to summarize, right? You have a bunch of data, right? So these are just a bunch of numbers all over the place, not organized, not arranged, right? We take that, we turn it into a frequency table. We organize it, right? There's an interval, there's a tally, and then we actually figure out the frequency, right? So we take data, we turn it into a table, and then we can either go histogram or we can go frequency polygon. Right, a histogram looks like this. Right? A frequency polygon is more like this. Okay. So just to summarize what it is that we try to do here. And then the line plots can be done apart from this, right? You don't need a frequency table to make a line plot. So keep that in mind. All right. Let's keep going a little bit more. I just want to do the next page there. So come with me to page 11 here. And I guess the title says it all. So come with me to page 11. I know it's early in the morning. You probably are thinking of better things to do than this, right? But don't blame you. Calculate the mean and standard deviation of a frequency table, right? So you're going to figure out the mean and the standard deviation of a frequency table. Okay. When you're presented with a frequency table, you do not know the value of the individual points, right? You do not know the value of the individual points. In such cases, we simplify, okay? So step 1, we calculate the midpoints of all intervals, okay? Step 2, enter the midpoints into L1 and the frequency into L2. Midpoints into L1, frequency into L2. Then it's one variable stats. Watch what it's doing here. L1, comma L2. Very important. And that arrow is supposed to go toward the L2, right? You must enter 2 columns, right? The entries in L2, entries in L2 indicate the number of values in that interval. I'm going to ask you to do this here while I do my attendance. So this is just a table with individual values, right? Individual values. So this is what you're already used to. So I want you to calculate the mean, the standard deviation, and range for the salaries and tell me how many employees work for this company. Okay, so enter this into L1 and then figure out that. I would expect you to do that by now, and then I'll do the next one with you. I'll just give you the answers. So please at least just tell me, you don't have to give me all the entries, right? One variable stats, that is, L1, right? You're just using L1 because you're entering all of this into just the L1 column, and your average is 3,835.25. Your standard deviation is 914.22. And the range of salaries is simply the greatest minus the smallest, right? So 6,500 minus 2,750. And that is 3,750. That is your range, right? So you've got your mean, standard deviation, and range. I haven't talked a whole lot about outliers, but if you had to pick an outlier, which one would it be? Which value is significantly different than the rest? Unfortunately, I haven't entered this into my calculator, but it stands out when you sort quite a bit, right? You'd have to notice the 6,500 being significantly different from the rest, right? So if you're ever asked, okay, outlier or outliers, right? If they ask you, it's like, are there any outliers? You would have to, in this case, say 6,500, right? Weekly salaries, right? Why would this be maybe? Okay, could be the CEO, right? Could be the CEO of the company, right? The boss, right? That's why maybe there's an outlier. So if I ask you for an explanation, just say, right? I know there's one about traveling times to work, like commuting times to work. If it takes you really long, like if you have one day where it's like ridiculously long, maybe you had a flat tire, right? Maybe there was an accident, right? Or there was a train that delayed everything or something like that, right? So outliers usually have an explanation. So just be creative. Okay. What about this though? The following table shows the weekly salary for company B. Right? Calculate the mean, standard deviation, and range for the salaries. How many employees work for the company? Oh, I didn't answer that here, did I? Can I do that here? What was N for us in this case? 4 times 4 is 16, right? 16 employees. Sorry, right there. 16 employees. I didn't answer that. But that is N in our case, right? We entered 16 values, so we know that there's 16 employees that we're considering for this company. Let's do the same thing for company B, but this is a frequency table, right? You should realize, hey, frequency table. Okay. Let's see if this stands out here. No individual values are given here. You don't actually know the individual salaries. They're grouped up, right? These 2 employees make anywhere between these 2. These 5 anywhere between these 2. So what's the first thing you need to do when there's a frequency table? Midpoints, that's right. Okay, so you automatically introduce another column just before it, and we'll figure out the midpoints. And this one will not be too difficult. Okay, so basically I will show the work for one of them. You do not need to show me this for every single one. Okay, so you go 2,000, like you add up these 2 limits, you divide it in half, and you get 2,250. Okay, you do the same, and it makes sense. It lies between these 2 values, right? And then the next one is 2,750. And then the next one is 3,250. And the next one is 3,750. And then this one is 4,250. Okay, so we keep on doing this, right, to figure out the midpoints, the point in between the bar, so to speak. And so because our calculator, you can't say, oh, I'm just going to enter this or this. You can't do that. A calculator doesn't do this. So this is what we use for it. So watch what we do here. We turn this into L1, circle it, right? And the frequency goes into L2, right? This is our frequency. You're like, what about the tally column, Mr. Dirks? Well, if it's already a finished frequency table, that's not needed, correct? So this is the frequency. Frequency is right here, is this column. So what we do is, grab your calculators. I'm going to clear whatever's in there. Remember, if you delete a column, do you remember the trick to bring it back to life, right? You go setup editor, enter, just run that, and then everything will be back as before. Okay, so we go 2250, 750. So enter everything. We enter the midpoints, remember, and then L2 gets the frequency. Okay, so L1 and L2. Before I run my one variable stats, I'm going to actually show here it's one variable stats L1 comma L2. You have to do it that way. So we go stat, calculate, just like before, but we go L1 comma L2, and then hit enter. And here it is. The average salary for this company is $32.10. The standard deviation is $467.33. My range is 4250 minus 2250, which is just 1500, right? Got all of those, sorry, standard deviation. And how many employees work in this company? You see it right there. N is 25, right? N is 25 employees. If you don't do the L2, so let me go back and run that again. So let's say you forget. That's what happens quite often. Students, like your test, whatever, you're going too fast. You're just going to go L1, right? How many employees are we now considering? Only 5, right? So you're basically, if you just enter this, it's assuming that these are the 5 values that you're considering. That's it. Yeah. Sure. So I quit the screen, and then, so let me just clear this. Stat, calc, right? One variable stats, and then I go second 1, and then comma, second 2. Okay. Some of you have the wizard, right? The Wizard of Oz. Okay. I should have done that a long time ago. So that we're all on the same page, I'm going to ask you to do this with me. Okay. You go mode, and there's stat diagnostics at the very bottom. Stat diagnostic and stat wizard. Turn them both off. Unless you're happy with, unless you've been working with the wizard, turn it off, right? Like if you don't like it, if you want to see what I see, then that's what you do, okay? So try it again, stat calc. Does it work now? Yeah. If you've been working it and it's just fine, then leave the wizard on, right? And I think maybe it's worth just telling you what the wizard does. It won't magically give you 100%. That's not going to happen, right? That's what you're hoping for. But it kind of does this, right? So the list would be in L1, the frequency would be in L2, like that, and then hit enter, enter. It does the same thing. but I personally turn it off. Sometimes when you do regressions, it's even different, right? It looks even different. So I turn that off. Good question. Okay, so let's talk about now that we have the mean standard deviation for both companies. Now we can compare them. Okay, so let's do that here. Now I'll kind of guide you through that. Um, let's put them side by side. Like company A has a mean of 38. What happened there? 38, 35, 25. Standard deviation of 914, 22. And yes, you could put the range in there too, but you will soon realize that these two are the ones that give us enough information, right? Because you already know the relationship between the standard deviation and the range. Actually, I'm going to give that AC back to you. I liked a lot of you wrote good stuff, and I actually gave you marks for that. So I really like you seem to understand how the range affects the distribution of your data, right? Big range means spread out. Small range, close, clustered. Like you use words such as clustered, closer to the mean, stuff like that. I actually give you marks for that. So I'll give that AC back to you. So what I will do is, like, I'm collecting these two pieces of information, and then I will say this. Company A has a greater mean. Right? This indicates that it pays more on average, right? On average. On average, it pays more than company B, right? Company B, right, has a smaller standard deviation, which indicates more consistency within salaries, within employees' salaries. There's consistency with employee salaries. And why do you think that would be a good thing to be consistent with salaries? Like if you're in a hockey team and the superstar makes 10 million a year and you just make 2 million a year, right? Like if there's a gap in salaries, there's probably going to be some rivalry or maybe some hard feelings, right? You may disagree or agree with that, but right? But there's inconsistency, there's a big gap, right? If a company has more consistency, they're closer together, that might be a, we're not saying it's a bad or a good thing, we're just stating the obvious, right? If you have a smaller standard deviation, indicates more consistency within what? Within salaries, right? So kind of connected to the context at hand here. Why do you think company A may be a bit more inconsistent? What will have driven the inconsistency? And the answer is the outlier does that. The greater right? The greater the distance from the points to the average, right? Like if you have one way far out, it actually spreads your data, right? The range becomes bigger, which makes it also makes the standard deviation be bigger as well. So keep that in mind. Okay, so now what I'm going to ask you to do is you grab your workbook. There, I want you to work on pages. It says here pages 5 to 8 at the bottom of page 10. I'm just going to confirm that. Pages 5. Yeah. So if you go to page 10 at the bottom, it says this, right? I want you to practice your graphing. But I will tell you, if you grab your workbook and you go to page 5, you already know how to make a line plot, right? So I will kind of say optional, but I will ask you to circle question 2 on page 5. Okay, so the ones that I circle, I strongly recommend you do. If you go to page 6, that's the only one there. I would ask you to circle that. And there's something special about this one. It's a frequency table. Be very careful here. So you're still going to have to find the midpoints. This is going to be one line on your graph. This one is going to be a different line on your graph. So it's almost as if it's saying, hey, make a graph for this one, a frequency polygon actually, and then ignore that one and make a graph for Saturday. I did them on the same grid. I graphed them both on the same grid because you have the same midpoint. So I use different colors. You might use solid and dashed lines. I will post the key and then you know what I'm talking about. Okay. Let me see here. If you go to page 7 and 8, I would say I would just circle page 7, question 1. So basically three questions that I'm asking you to do. These are all graphs, right? So you choose if you want to do all of it, that's great. If you want to do some of it, the ones that I circled, that's good too. And I will look for the answer keys and post it. You can check it as you go. But make sure you use the class time wisely, right? That means you take control of your phone, right? Check it and then get to work, okay? And that is everything for tomorrow. Make sure you know how to do the graphs. And also make sure you know how to deal with a frequency polygon when I ask you to find the mean, standard deviation, and all that. And really the only secret is midpoints and that you enter L1 and L2 into your calculators. Okay, that's it for now. I'll come back a little later. And you have your frequency here and go for it there. Okay, so all the keys are posted for everything. Give it a try, give it a go to make sure you become comfortable with it, because if you take too long, it's going to eat away from the other stuff, right, that you need to know. Okay. What I'm also going to show you here